Welcome to the Authority Podcast, Plumbing and Mechanical. When talking about the built environment, we would do well to remember, we shape our buildings, and afterwards, our buildings shape us. Therefore, on each episode, we'll discuss the latest trends from IAPMO in plumbing and mechanical safety, sustainability, and resiliency. Join me, your host, Christoph Lohr, and together we'll explore the ways we can make our buildings shape us for the better. And welcome back to the Authority Podcast, Plumbing and Mechanical. I'm your host, Christoph Lohr. And in this episode, Robert Campbell Sr., Director of Multifamily Commercial Operations for the Plumbing and HVAC divisions of Villara, and Amanda Johnson, Plumbing Design Supervisor for Residential New Construction from Villara as well, are going to tell us how they save on new home construction costs by using the IAPMO Water Demand Calculator, a game-changing tool that helps builders and developers better understand and manage water usage in construction projects. The IAPMO Water Demand Calculator also promotes housing affordability by right-sizing plumbing pipes. Right-sizing plumbing pipes can save up to $5,000 in construction costs based on one study by Stantec and related meter connection charges. Villara has saved costs for more than 5,000 single-family homes using the IAPMO Water Demand Calculator. Robert, Amanda, thank you so much for joining us today on the episode.
Thanks for having us.
Thank you for having us.
Rob, tell us about Villara and your role as the Director of Multifamily Commercial Operations for the Plumbing and HVAC divisions. What are some of the key responsibilities in your position?
All right. Well, at Villara, we are a mechanical and plumbing contractor here in the Northern California area. We actually have projects all over the state of California, from San Diego all the way up into the Northern California area. Residential new construction to multifamily to renovations. We do just about everything. If somebody sleeps there, we're probably on the job or will be soon. And we do a lot of commercial work also. So company's been around for many, many years. It's been recognized as one of the larger West Coast companies. And so we've been around for a while. As far as my role here as Director of Operations for the Multifamily and Commercial, I oversee a team of division managers and operations, sales, estimating, design for all of our multifamily and commercial projects for both HVAC and plumbing.
Excellent. And then Amanda, for our listeners, as the Plumbing Design Supervisor for Residential New Construction, what are some of your key responsibilities in your position?
So I oversee a team of designers, and we do city submittals as well as the designs for all of our contracted install work.
Excellent. Well, let's jump right into kind of what the meat was and as what I was talking about during the introduction here, which is the water demand calculator. IAPMO, an official magazine, just recently had an article about you all talking about your work in utilizing the water demand calculator for many, many years in California. How has the IAPMO water demand calculator helped Villara promote housing affordability for your clients? Rob, do you want to maybe take a start at it, and then Amanda chime in?
Sure. Yeah, I think so. For many years, if I could just kind of look at the history of plumbing, this year marks 40 years I've been in the business full time. And, I learned in a union shop, and we learned how to properly size and right size. But I worked for many companies throughout the years where training and education was never a part of the training. It was more about production and get it done. And when cost of materials weren't an issue, it really didn't matter if we oversized the cold water system. It really didn't matter if we oversized the hot water systems in people's minds, because for velocity reasons, better to go larger than to go too small. So when cost became an issue, we started looking and worked with several different people on looking at ways that we could reduce costs for our customers in order to make housing more affordable. And through that, we were introduced to the water demand calculator, and probably in its very, very early stages. Amanda might be able to talk more about how long we've been using that. But it was kind of a very preliminary tool. But what we noticed was that we could reduce the cost in both materials and labor by right sizing the system. And we also recognized that for the environment, we were wasting a lot less cold water down the drain by right-sizing the hot water systems so that when we were displacing cold water, waiting for the hot water, we could get hot water to the end user a lot quicker by right-sizing the system. So those cost savings, it came down to saving our clients money because, it wasn't just necessarily extra profits in Villara's pocket. It was to give us the ability to try to make housing somewhat more affordable in our small part of what we could do.
Excellent. Well, I guess kind of jumping to the next question here, it would be great to hear some specific examples of how Villara has saved new single-family home construction costs using the IAPMO Water Demand Calculator, and trying to figure out what kind of savings we're talking about. Amanda, do you want to touch a little bit on like what you've noticed in the design process, and then maybe Rob, you can touch on maybe some of the construction cost savings you all have seen?
Yeah, definitely. So, like Rob said, we were introduced to the calculator and this change of using probability of use and kind of a more reasonable way of sizing versus, imagining everything running at one time. And like Rob said, it just in these new homes, the size would be inch and a quarter or inch and a half. And so, incorporating the probability of use really reduced our sizes to, 1 inch supplies. And so the size that could be on 1 inch and 3/4 and 1/2 inch was a lot more fixtures. Um, so it was a real improvement from Chapter 6 and Appendix A, where it was just imagining everything running at one time. So it's, yeah, greatly reduced the sizes. And like you said, the delivery time is better and the waste of water is less. Um, Rob could probably more on cost or estimate.
Yeah, from a cost standpoint, well, I'd like to give a specific example first. We had a project in San Mateo that the owner wanted to add automatic washers to the site. And so the mechanical engineer drew an entire new cold water and hot water system to supply those automatic washers in all the apartments. And the cost went outside of the owner's ability to build the project or to remodel the project. And with the water demand calculator, we were able to use the existing pipe sizes by proving with the probabilities of use, we could support the use of adding an automatic washer in every unit by using that. So it made the difference of a lifestyle change to people's lives because now they have laundries in their apartments. So I say that to transition into cost. We can build new products with smaller size pipings. We can renovate existing projects without upsizing and adding additional water mains to support additional plumbing fixtures. Amanda made a good point before the podcast started that it's hard to correlate exactly what that cost is because through the years of COVID, prices accelerated so much and so fast that it's hard to take data and compare construction costs today using the calculator versus construction costs from when do you compare it to? But a few examples. A smaller water meter saves thousands of dollars. A smaller PRV saves hundreds of dollars. Labor is expensive. In California, we pay a premium for labor. At Villara, we pay we pay a very competitive wage for our personnel. If we can reduce pipe size, we reduce labor costs. We reduce material costs. All these things give us a competitive edge as a contractor. Maybe I shouldn't tell all of our secrets, but it gives us a competitive edge. But that ultimately is passed down to the Lennars of the world, right? The KB Homes of the world, who then can pass those savings on to the end user, the people buying houses. And with interest rates where they are today, every $100 on a house could make the difference between somebody being able to purchase a house and not purchase a house. And we look at it as for our longevity of our careers, we've got to stay in business too. So we've got to move with the market conditions. And we're in a market right now where it almost supports or dictates the use of the water demand calculator in order to provide the end customers what they're looking for.
Excellent. Well, and I guess that kind of leads to sort of that next question, talking about the end user, beyond the housing affordability benefits, what other benefits has Villara experienced by incorporating the IAPMO Water Demand Calculator into your construction planning and processes? I mean, has it impacted things like customer satisfaction or water quality issues at all, or any other benefits that you can think of? Maybe Rob and then Amanda.
Yeah, well, like I already mentioned, by right sizing the water using the calculator, we're reducing pipe sizes. We're maintaining proper velocities. We're reducing pipe sizing, so the end user experiences a better hot water system. So we get hot water to the end fixture quicker by reducing pipe sizes. That's probably the most important one. Water quality, yeah, I'm not an expert on that, but I would speculate that the less water that we have just hanging out, being stagnant in the line, the better quality that water we're going to get, because we're storing a lot less water in the pipes. There's just a lot of benefits from it that probably go up beyond my level of expertise. But as far as the homeowners, they're just happy to turn on the faucet and get water. And they're extremely excited when they turn on the faucet and get hot water. So we're providing a product that does both of those things for them, and we're also providing a system, I think, a proven system that's going to last many, many, many years. We don't have to worry about the system being undersized, too high of velocities where the system's going to fail. So it's a product that we can stand behind, and that's probably the most important thing that we do.
Excellent. No, that's a great answer, Rob. Amanda, anything you want to add to that?
Yeah, no, a lot of the same as far as like quality and everything. I think just being in California and our quality standards, and then just following all the codes and trying to right size everything. The quality really isn't an issue, or the flow isn't an issue. Hot water is a transition now with heat pumps.
Yeah.
Everyone loved their tanklesses. But yeah, we're trying to do the best we can to right size and design it as efficiently as possible.
No, that's great to hear. And it reminds me of a conversation I recently had with a county building official here in Arizona, where I'm recording from, and she was sharing with me how she used to live in a home where the water heater was further away, and kind of the idea, like with right sizing too, in terms of how fast that water gets delivered to you. And smaller pipe, like you mentioned, Rob, will deliver that water faster. Amanda, I think you mentioned it as well. And so in this case, the further away a water heater is, it also delivers the water, slower, the closer it is. And she described to me how, when she lived in this old place, she'd turn on the shower and wait for the water to heat up. And then when she moved to her new place that she lives in now, her new home, the water heater is right on the other side. It's an older home, so it's kind of smaller footprint. And she has one of those instantaneous tanks on the other side. And, it's funny because she's like, I turn the shower on now and I get in right away. I don't have to wait. And because that water gets delivered faster. And so I think one of these subjects that I'm thinking about a lot in that right now is, the human behavior. We adapt pretty quickly, sometimes even without realizing. And so I think, as you were talking, Rob, about the hot water being there more efficiently, I think there's definitely, some efficiency and behavior that occurs too, because people realize that hot water is there faster. They don't wait so long to step into the shower, because they don't, at least in Phoenix during the summer times, we don't have really cold showers. So we only can have hot showers or hotter showers. I think in NorCal, your water temperature gets a little bit cold in the winter time. So I was gonna say, maybe do wait on that. So that's a great point, Rob. And I think your point about water quality, the water sitting in the piping longer, is also an excellent one. I think that's something that we're looking at studying as well. Okay, so with all of that, I mean, that was a great segment that and just kind of answering a lot of questions there. Kind of turn the corner as we're wrapping things up here. What would you say to other home builders and developers about the IAPMO Water Demand Calculator? Anything on your end, Rob, and then maybe Amanda, you want to touch on what you would say to other designers on the subject?
Well, I think I would just lead with the answer to that question for home builders to know who their design engineers are, who their designers they're using. Make sure that they have a program for continuous education. Make sure it's a company like Villara, if not Villara, that just stays up with the trends and the new technology and the new codes. because the water demand calculator is a great tool for all aspects of the whole process, for cost savings, for construction, for better quality water for the end user, for faster hot water delivery. There's just many benefits, but you have to know who your designers are to know that they're doing it the right way. A lot of companies just don't stay up with the trends of all the new things, and it's just easy to go back to Chapter 6 or Appendix A. It's what I know. It's what I've always done. Trust me, I just started learning the water demand calculator recently, because if I needed it, I just said, "Hey, Amanda, help me," and I started studying it and learning more about it, and it's a fantastic tool. So just make sure that whoever you're using for your projects is up to date, and they're using the right tools for the right project.
That's great advice, Rob. Amanda, anything from one designer to our designer listeners in terms of using the IAPMO Water Demand Calculator?
Yeah, Rob kind of brought something to mind, something that's really awesome about our company and me having a team of people with all different experience and education is, always reevaluating it, and everybody, read it, play with it, what do you take from it, and kind of the accumulative ideas and interpretations, because the code can be interpreted many different ways. That, yeah, really staying up to speed. And I think, I'll look at other designers, and some I feel still way oversized, and some I think undersized. And it's not always, the more brains I feel like, in the pile, you can really come up with better ways and improve your philosophies and design styles, and making sure you're interpreting the code as best as possible, so that you design as efficiently as possible.
Excellent. I love it. Well, my last question to you all, if we are going to wrap up, each of you gets one word to wrap up our talk today, what would that one word you all would pick? So each of you has a chance here, and we'll go with Rob and then Amanda. So what is the one word to wrap up our conversation today, and why? So Rob, do you want to go first?
I'll just say one word, education.
Okay. And why would you pick education?
Because like I had stated before, I think, being old school myself, continuous education is just so important in our trade, because it's as simple as it seems. It's changing every single day with water demand calculators, with equipment, with high efficiency, with, tankless heaters to heat pumps. So being educated on all the products, all the tools available to do our job effectively, makes a company more efficient and more effective in the business place. And, that's good for everybody.
Excellent. I appreciate the wrap. Amanda, you're up.
I was going to say probability for probability of use.
I like it.
It's just so much more practical. It was really frustrating with, Chapter 6 or just Appendix A. So probability.
Excellent. I love it. Well, on behalf of Authority Podcast, Plumbing Mechanical, and also IAPMO, I just want to say thank you both for taking time out of your schedules. Thank you for sharing your expertise, your insights, and just really appreciate the time you took to talk to myself and our listeners today.
Thank
you for having us.
Thank you for joining us on this week's episode of the Authority Podcast, Plumbing and Mechanical. Love this episode of the podcast? Head over to iTunes to subscribe, rate, and leave a review. Please follow us on Instagram at IAPMO, on LinkedIn at IAPMO, or email us at iapmo@iapmo.org. Join us next time for another episode of the Authority Podcast, Plumbing and Mechanical. And in the meantime, let's work together to make our buildings more resilient and shape us for the better.